Good day, students. Here we come again for another class. Today, we shall be discussing logical reasoning. This is Ss1 Mathematics. Specific objectives. At the end of the lesson, the students should be able to define logical reasoning and then make simple and compound logical statements. Logical reasoning. Logical statements are statements of facts that may or may not be true. By this we mean that you make a statement and such statement must not be true. It may be true. For example, we say Nwosu is a very intelligent student. It may be true that Nwosu is a very intelligent student. It may not be true that Nwosu is an intelligent student. The second one says, my goats can read and write. Obviously, we know this one is not true, but it's a logical statement. So, if you hear, my goats can read and write, your reaction may be, it is not true that your goats can read and write. But here, what the statement is saying is, my goats can read and write. Imagine how true it may be. Okay, we say from the above two statements, it may be true that Nwosu is intelligent, but we doubt if any goats can read and write. Hence, the definition of logical statement. The truth value of a logical statement. Here we say the truth value of a logical statement is the result or outcome of that statement. For instance, we say that Nwosu is intelligent, and the truth value of the statement may be just true, represented by T to mean that it is true that Nwosu is intelligent. We also need to understand that the truth value of the second statement is actually false, represented by F, since no goats can read and write. Simple logical statement. Just like a simple sentence, a simple logical statement is a statement of fact that contains only one information. For example, Mr. Chidi is my mathematics teacher. It is a simple logical statement, but the truth value may be T, it may be F. It is T, which is true if Mr. Chidi is actually a mathematics teacher. The truth value remains F, which is false if Mr. Chidi is not your mathematics teacher. The above statement is neither derived from any statement nor implied to another. It simply stands on its own to make its own complete meaning. That's why we call it a simple statement, which is actually a simple logical statement. Then we'll talk about compound statements, which is also called a composite statement. We are talking about compound logical statement. So we say a compound logical statement is a statement of fact derived from the combination of two or more simple logical statements by use of some binary connectives like and, or, if then, if and only if. Let's go ahead to check where we have some examples. It says, for example, let P be the statement that Abuja is in Nigeria, and Q be the statement that Nigeria is in Africa. Then at least one of the following statements must be true. What are the statements? P represents Abuja is in Nigeria. Q represents Nigeria is in Africa. A combination of the two statements in any of the following forms will also give us another logical statement, which is actually called compound logical statement. The first one, Abuja is in Nigeria and Nigeria is in Africa. From the two statements above, you can combine them to get this statement, which is either true or false. Abuja is in Nigeria and Nigeria is in Africa. Is it true? The answer is yes, it is true. Another one. From the two statements, we can still derive a compound statement saying Abuja is in Nigeria or Nigeria is in Africa. This thing may simply read either Abuja is in Nigeria or Nigeria is in Africa. Another one says, if Abuja is in Nigeria, then Abuja is in Africa. Do you understand the meaning? Already you know that Nigeria is in Africa. So if Abuja is in Nigeria, then Abuja is in Africa because Nigeria, which contains Abuja, is in Africa. But it must not be true every time. Another one. It says Abuja is in Africa if and only if Nigeria is in Africa. Reason being that Abuja is in Nigeria. See it now. Once Abuja is already in Nigeria, Abuja can only be in Africa if and only if Nigeria itself is in Africa. That's also a compound logical statement. Can we move on? We go on. Logical operation. This should read logical operations stroke symbols. We say logical statements are usually represented by capital letters, just as we did here. We presented this Abuja is in Nigeria by a capital letter P, and Nigeria is in Africa by a capital letter Q. That's what we mean here by saying that logical statements are usually represented by capital letters. Now we say that certain mathematical symbols are also used to operate or connect logical statements. They are therefore called logical symbols and connectives. The symbols and the connectives are the implication. This thing means implies or sufficient. This one means is implied by or necessary. This is what we call double implication. It goes both forwards and backwards. So we call it by implication, means implies and is implied by. Implies and is implied by. That's why it is called by implication. By means two. Implication, here you have seen it. So by implication means two implications. By means two. That means implies and is implied by, and can also be called necessary and sufficient. As we go on, you will begin to see how to use all these logical symbols and connectives. This is a logical connective called conjunction. Ordinarily, it means and. This one is disjunction. Ordinarily, it is called or. This symbol is called negation, which means not. Assuming you say P means a particular logical statement, then the negation of P means not that logical statement. So we carry on. By examples, we say that P should represent that Femi lives in Abuja, and Q should represent that Femi lives in Nigeria. P implies Q means Femi lives in Abuja implies that Femi lives in Nigeria. Because of what? It is only in Nigeria that you can get Abuja. So if Femi lives in Abuja, it implies that he lives in Nigeria. But is the convert true? if the converse statement is made, is it necessarily true? That if Femi lives in Nigeria, then he lives in Abuja, it may not be true. Because Femi may live in some other places. So we say now, if Femi lives in Nigeria, must he live in Abuja? And the answer is no. He may live in Lagos, which means that if P implies Q, Q must not imply P. Do you understand? But we shall go ahead to see if there is any way P implying Q will also mean that Q implies P. So we say M means Mary is Emeka's sister. The M representing the logical statement Mary is Emeka's sister. Another logical statement M is saying Mary's mother is Emeka's mother. The first one says Mary is Emeka's sister. The second one is saying Mary's mother is Emeka's mother. So what do? We go on. Mary is Emeka's sister. Mary's mother is Emeka's mother. Now, M implies N means Mary is Emeka's sister implies that Mary's mother is Emeka's mother. I think this one you know it is true. If you are my sister, then your mother is my mother. Again, Mary's mother is Emeka's mother implies that Mary is Emeka's sister. We check it here. Mary's mother is Emeka's mother implies that Mary is Emeka's sister. Is it true? Yes. It means that once this statement is made, the converse is also true. If this is true, the reverse is also true. As a result of that, if M implies N and N implies M, both of them being true, then M implies and is implied by N. Recall that this one means M is implied by N, M implied by N, showing Mary is Emeka's sister is implied by Mary's mother is Emeka's mother. Combining the first, second, and third, for which the second is actually talking about the third, we shall get the conclusion that Mary is Emeka's sister implies and is implied by Mary's mother is Emeka's mother, meaning M implies N and is implied by M. That's it. We go ahead, continuing the logical connectives. Take a logical statement A to mean Said went to market. Another logical statement B, Said is in chemistry lab. A, operation B here means the conjunction of A and B will mean Said went to market and he is in the chemistry lab. It may or may not be true. See how this thing will be true. Said went to market and he is in the chemistry lab will only be true if the chemistry lab is in that market. But if the chemistry lab is in the school and the market is not close to the school, this statement will not be true. He cannot be in the market and still be in the chemistry lab where the lab is not in the market. You have to think. But this one is the disjunction between A and B. It means Said went to market or he is in the chemistry lab, but at least one of the two must be true. We can also read this one to mean either Sayed went to the market, or he is in the chemistry lab. That's what we have done here. Remember, conjunction and disjunction or negation of logical statements. If the truth value of a given logical statement P is represented by T, then the truth value of its own negation, known as the negation of P, is false. The truth tables. The truth tables are mathematical tables used to represent the logical information which is to be discussed after this particular class. You will get this one possibly on Friday. Let's go ahead clearing the roads for the coming topic. We shall end here. We say thank you, my dear students. What you have to do for me is, having seen all these things, you have known the meaning of the negation of logical statements. What you have to do for me is check every material around you and go through what is called conditional logical statements. That's where we shall be going into in the next class, from where we shall get into the logical tables. So we shall get to logical tables after studying what we call the conditional logical statement. So do me a favor, by going through the conditional logical statements from any material that you have around you in mathematics. Otherwise, Google it and check what it means before getting into the next class. Thank you very much. God bless you as you stay at home and stay safe.